Welcome back, dear students. Though this is a physics channel, but yet today I am going to discuss a mathematics question, because this question is a very much hyped question which I found on the internet, and it recently came in the mathematical Olympiad on 7th of September. So I found it on the internet that many of the teachers got puzzled and they found it very tough. Even the very good coaching teachers, they couldn't solve this question in their online session. So I wanted to give it a thought, and to my surprise, this question is undoubtedly a very good question, but it is not a tough and complicated question, provided you visualize the diagram properly and simply apply the basic trigonometry without committing any silly mistakes. So I want you also to give it a try, and let me show how such a complex question, so-called complex question I must say, can be easily solved by visualizing the diagram and applying simple trigonometry. So the question says, let S be a circle of radius 10 with center O. Suppose S1 and S2 are the two circles which touch S internally and intersect each other at two distinct points A and B. If angle OAB is 90 degree, what is the sum of radii of S1 and S2? That means the question is something like this. Let it be a bigger circle and it has two internal circles which are something like this. This is a chord, and suppose this is, let's draw a proper diagram, because here it is something like this. Let this be the center O, and somewhere here there is a point A and a point B here. So two circles are there, one this one and other something, though I am not very much diagrammatically correct, but the idea is two circles having the same chord need to be drawn so that they touch the bigger circle internally. So here is the clear diagram. What is happening? Let this circle be the bigger circle S, and this is the center of the circle. Let us assume this as a diameter, horizontal diameter I will call, and we can take the point A anywhere. We are at liberty. The question doesn't force us to take it at a fixed point, but we need to take only satisfy the condition that OAB is 90 degree. That means if we are taking A somewhere here, then we will have to take point B just below it, along the vertical line, so that angle OAB is 90 degree. So let me take A and B something like this. I am taking A here and I am taking B here, okay, and this distance I will take as x, okay, purely general distance I am taking, and this chord length I have taken what? L, okay. Now how many circles do you feel can have AB as a chord and at the same time they are touching the bigger circle internally? Only two options are possible. One is this one. This is where your visualization comes into picture. It will be touching this circle at here. Other will be this circle. It will be touching at this. Any other circle you take with AB as a chord, then it won't be touching the bigger circle internally. You can try yourself. It is not possible at all. So, and now what you can say, if this point O1 is the center of a smaller circle and this point O2 is the center of the bigger circle, then this line O1 O2, this will be perpendicular to the this will be the perpendicular bisector of the chord AB, that you already know. That means if what we are going to do, what our approach will be, we will be considering simple this smaller circle and I will assume its radius to be r. Applying simple trigonometry, I will get r in terms of x and L. What do you think the nature of this equation will be? I've already told you we are getting two radius values, this and this. So the nature of this will be a quadratic equation. It will come something like this, so that it has two roots, AR square plus BR plus C equal to 0, where A, B and C will be something in terms of x or L. So this will be the equation, and its roots will be R1 and R2. R1, R2 will be what? r1 will be the radius of this smaller one and r2 will be the radius of bigger one. So what will be the sum of the roots? We have to find r1 plus r2, as the question is asking what is the sum of the radii of s1 and s2. So we have to find r1 and r2, and what is the formula for the sum of the roots of a quadratic equation? It is simple, minus b upon a. So now our strategy is pretty clear. We will be just developing a quadratic equation of radius r in terms of x and l, and finally we will just find the coefficient ratio and our answer will easily come. Okay, so let us see in a clear diagram now. This is the situation. Let me call it as O, this as O1, and this point is already A, this point I am taking as C, and this point I take as D. So OA is X, we already know, and this line center to center, this was the other circle center O2, this was the perpendicular bisector of AB. So this AC is what? This is L by 2. This is L by 2 if chord length was L. So you see in a bigger picture, this is O, this is A, this is D, this is O1, and this is C. So this is what? This is L by 2. This is what? X. And if I connect OA1, O1A, sorry, what do you think? What is this? This is simply R, the radius of the circle. So this OA1 is R. And what can you say about OO1? OO1, what can you say? If you take this connection point as P, then OP is what? OP is the outer circle radius, which is 10. Then OO1 will be what? 10 minus simple R, 10 minus R, because O1P is the R. So OO1R, I mean this total length, this is what? 10 minus R. See how easily you can attempt and solve it. Okay. So now let us apply the trigonometric equation. Again, I mean same thing here. O, O1, A, C, D, and this one L by 2, and this one X, and O1A is what? R, and this one is what? 10 minus R. Now you see what will be AD? Here you can see very easily AD will be what? R square minus L by 2 square. I mean under root AD is what? AD is R square minus L by 2 square. Okay. So now you come to triangle OO1D. OO1D, you simply apply Pythagoras theorem. So what you get? You get X plus AD. This is AD. That means X plus AD R square minus L by 2 square whole square plus what? L by 2 square equals to what? 10 minus R square. This is simple Pythagoras theorem in the triangle, in the right triangle OO1D. Okay. Now if you simply solve it, then what you get? Many of the things will cancel out and you get what? You get X square plus R square minus L by 2 square plus 2x and R square minus L by 2 square plus L by 2 square is equal to what? 10 minus r square. This is 10 minus r square. Okay. Now you see here what are the things cancelling. I mean you also expand this one. I mean you just further write it as 100 plus r square minus 20r. Now you try to cancel out the things. This L by 2r square cancels this one. This r square cancels this one. And so what remains is simple x square plus 2x. What remains is x square plus twice of x times r square minus L by 2 square equal to 100 minus 20r. Okay, 100 minus 20r. Now our aim is to get a quadratic equation in terms of r. So we will bring this x square in the other side and we will write 2x r square minus L by 2 square. This side we will try to separate out r, so we will write it 100 minus x square minus 20r. Now we need to just square both the side and we will get a quadratic equation. How? 4x square times r square minus L by 2 square equal to square this complete. What you get? 100 minus x square whole square plus 400 r square minus 40r times 100 minus x square. Okay, the calculation may be a bit lengthy, but finally we will be getting a very easy solution. So now you just collect the coefficient of r square and you try to formulate it in terms of a quadratic equation. I mean try to just bring it in this form: ar square plus br plus c equal to 0. Try to bring it in this formulation. What you have to do, collect all the r square terms in this direction. So r square here and 400 r square here. So what it will be getting? R square times 4x square minus 400. This is the coefficient of r square plus coefficient of this one r, this bring this side, so it will become 40 times 100 minus x square times r plus all the other terms like this one, L by 2 square x square, all the other terms don't matter to us. So we write it in a combined form as c and it will become as a 0. So now see, we got ar square plus br plus c equal to 0. Now it is very easy. So what is the sum? Let its root be r1 and r2. As we told, sum of these two are essentially the radius of the S1 and S2. These are the radii of S1 and S2. So you need to find their sum. That means R1 plus R2 is simply sum of the roots of this equation. Root is what? Minus b upon a. What will be minus b upon a? Here you see minus b means 40 times x square minus 100 minus b upon a. What is a? 4x square minus 400. So take 4 common. So you get 4x square minus 100. So both up and down cancel and you get R1 plus R2 as 10, which is the final answer. So see how easy this question was, provided you apply a bit of trigonometry, a bit of quadratic equation and a bit of your visualization. So I hope you like the solution, and if you like the solution, please like and share and subscribe the channel. And if you have any questions, any suggestions, any doubts, please feel free to ask in the comments. Thank you.